Good evening. So I just want to check the sound first, make sure that's all looking good, and then we'll go. So it's 1 minute to 7, or less than 1 minute to 7 now. 39 seconds. First, make sure that's okay. Yeah, I'm happy that the sounds and seems to be okay. So let's get underway. And well, last night was a bit of a interesting thing there with the old chat GPT, and I left you with a question, actually a question overnight, which I asked ChatGPT to check, and I checked it out myself, and yeah, true to form, ChatGPT was a little bit wayward with that question. So we've now got a revised question here, and you can see it there. What we've got is, at a school fundraiser, 19 tickets were sold in total. So the child tickets were $2 each, and the adult tickets cost $5 each. If the total amount collected was $62, how many child tickets and how many adult tickets were sold? Sort of trying to simulate a real situation, but not really. You'd probably have different tickets and you'd know at the end, but anyway, bear with me, and we'll have a go and see how we go about this one. So total tickets was 19, so that would be, let's say, let's use A for adults. Try and get what's happening here? I've lost my my pen is gone. Oops. Oh, golly, I'm in a bit of trouble here. Maybe I should turn. Oh, there we go. I've got my pen. I've got it back now. Oops. Yeah, that's better. Okay, and yep, that's all good. All right, I think we're ready to go now. So let's just lock that in place. Yeah, so let's say A for number of adults. So A is for the number of adults. And yes, C would be for the number of children. Yep. So we'll just use that. So the total number of tickets is 19. So therefore the adults plus the children equals 19. And we know that the total amount collected was $62. So that would be the number of the number of adult tickets times 5, or 5A, plus the number of child tickets times 2, and that would equal 62. So now we've got two equations that model what happened. So yeah, we've got two equations that model what happens. So what we can do is let's multiply equation 1 by 2. And so that's going to give us 2a plus 2c equals 38. We just multiplied that by 2, and that's equation 1 multiplied by 2. Now we're going to subtract 5a minus 2a is 3a, 2c minus 2c is 0, and 62 minus 38, 4, 8 from 12, 24. And so now we divide 3 by 3. And subtract, and we get a equals 8. Okay, and then we substitute in 1. And we get 8 for A plus C equals 19. So C equals, we'll subtract 8 from both sides. And C equals 19 minus 8, which equals 11. All right, so there you go. C equals 11. All right, let's just test that out. So we've got A plus C, so 8 plus 11 equals 19, correct. And then let's go 2 times 8 plus, oh sorry, let's do that around the other way. That's just the same equation. 5 times 8 plus 2 times 11 equals 5 eighths of 40 plus 22, and that equals 62. So yeah, they're both pretty good. We're not actually dealing in X and Y here. So, I mean, we could graph this in XY, but probably not worth it. Well, I think we've done plenty of that. So yeah, that's pretty much it. What we can do is just check it out here, just to see what ChatGPT's got to say for itself. All right. So let's go here. Adults 8, children 11. Okay, I've got to click this button here. See how that goes. Oh, what's it doing? to do it on my phone. Okay. We're having a wee bit of trouble there. Come on, golly, it's really a bit of a letdown, isn't it? Okay. We got 8 adults and 11 children. I think what I'll do is I'll restart this. I'll just come out of there. Okay. Right. And we got 8 adults and 11 children. Yes, there we go. All right, so finally we see that we've got it. Bang on the money again, perfectly solved. Want a real lifestyle one next, maybe involving trades, people, supplies, or food. I think I'm going to leave that there. So one of the things that I've identified is that ChatGPT struggles with these. So I'm going to create a real life situation, and we're just going to have a look at something which will increase our knowledge a little bit on graphs. So let's just say, for instance, that you are a teacher, or a tutor, and you're wanting to write a question like one of these types of questions that has a that intersects two graphs, and they go through a point. So let's see if we can do this here. And there's our x and y axes. So again, I'm just I'm doing this live. I haven't really prepared for it. I just thought about the idea. So I'm just working through it. So let's say, well, let's choose one that's fairly, and let's just say I've got that point there, 3, 4. Okay. So that's my graph there. And I want a graph going up here somewhere. Like that. Okay, so and let's say this here is -2. So I want a graph, or a straight line, that goes through the point. Oh, it's not the 0.34, it's the point. It's the 0.43. And -2 0. That's the y-intercept. Okay, so our graph is going to be y equals mx minus 2. That's what our graph is going to be. We know that our y-intercept is there. And we also know that m we know that's going to be y equals mx plus 3, and we know that it goes through the point 4, 3. So we know that's it there. So if it goes through the point 4, 3, so from that we can say at 4, 3 we can say 4, which is y, equals m3, 3m. Oh, sorry, wrong. I keep getting around the wrong way. So we can say 3, which is y, equals m4. I'll put those in brackets to see. Minus 2. And so we now get, we can manipulate this, we can add 2. So we get 3 plus 2 equals 4m. We can divide by 4, and we get m equals 5 over 4. Okay, so the equation of our graph is y equals 5 over 4x minus 2. And if we multiply that out to put it in that the format of the the equations, we can go times 4. We get 4y, okay, minus 5x equals negative 2. So here we did minus 5x to get that. Okay, 4y minus 5x equals negative 2. So that's one of our equations that we could use for a simultaneous equation. Now the next one we want to do is we want another graph that goes through that point. I'm going to draw that there like that. And that one there has a y-intercept of, let's say, 6. So we'll just, we're now going to do the same thing. So now we've got one with y-intercept 6 goes through 4, 3. Okay, so we can say y equals mx plus 6, because that's our y-intercept. Okay, and then at 4, 3, we get 3 equals 4x plus 6. And then oh, 3 equals, that's m, 4m plus 6. And so we get 3 minus 6 equals 4m. 3 minus 6 equals 4m. So there we just, yeah. Oh, then we just minus 6. And then we divide by 4. And we get m equals negative 3 over 4. Okay, so our equation, y equals negative 3 over 4x plus 6. And if we look at our equation, we can see that that's a negative curve. Right, and now we'll multiply that out. 4y plus 3x, because we multiplied everything by 4. 4y plus 3x, because I've put that over the other side, equals 24. Okay. So now we've got our two equations. 4y plus 3x equals 24, and 4y minus 5x equals negative 2. Right, so that can be equation 1, and that can be equation 2. So this is how, you'd have to go about doing it. And I've already drawn the ones there. So this is a bit like undoing stuff and then redoing it again. And that's how it goes. Take it apart, put it back together again. So here we're just approaching it using the same skills but from a different angle. Right, so let's multiply, well, let's just take them away. It's easy enough. It's already so all we have to do is subtract. So that's 8x minus negative, 3x minus negative 3x, that makes it 8x. Okay, so that's 8x equals 24 minus -2 equals 26. So I've got something wrong here. Four y minus 3x plus 24. Minus 5x minus 2. I'll just have to, I've made a mistake somewhere. Oh, 4y minus 5x. That should be 4 2s are 8. I forgot to multiply the 2 by 4. It's going to multiply everything by 4. So that would be -8. And this would be -8. Yes. And then this here would become 32. Right. And then we divide through by 8. And we get x equals, divide through by 8. X equals 4. Yay, which agrees with what we were trying to do. Exactly. So that's right. And then we can look at one of our equations. We'll substitute into, okay, we'll substitute into equation 1, sub in 1. And there we get 4y equals, oh no, it doesn't. 4y plus 3x equals 24. Okay, and so that gives us 4y equals 24 minus 12. We divide through by 4. And we get y equals 3. Okay. The graphs intersect at 4, 3. Okay. So let's just recap on all that there. So what happened was last night we tried a real life problem and it didn't actually work out. And then I gave you one to look at over the break, or the next night, and I revisited it, and it needed some change, but I finally got it right, and that's the one that we looked at, and that was a bit of a real life problem. So we had to create the equations and then solve them. So then next I said, well, ChatGPT had a lot of problems making these whole number ones. So let's choose a point that we want to be the intersection. So sort of, I guess it's called reverse engineering. We reverse engineered it and took it back a bit. And yeah, so I chose the point 4, 3 and said, okay, let's draw a line through that. And the first one I chose, I said, well, let's have one with a y-intercept of -2. So that enables us using y equals mx plus c, well, we know that the y-intercept is -2, and then we know a point on the line, so we can substitute that, and we're able to work out what the equation was, and in this case it was y equals 5/4x minus 2. Now, the simultaneous equations, they were in a different form where they didn't have a single y coefficient. So to do that, we had to multiply by 4, and so we get 4y and minus 5x equals, now initially I put -2, but I should have multiplied that by 4 and made it -8, which I found that mistake out later on as we're going along. This is live, so yeah, I don't prepare them beforehand. This is sort of how it happens, I guess, in real time. So then we went to the next graph that I wanted, or line, and that went through the same point, which was the point of intersection, but it intersected at +6. So just repeat the same thing really. Y equals mx plus 6 this time. Goes through the point 4, 3. So you can substitute 4 back into the equation. Every time there's an x, you put 4, and every time there's a y, you put 3. Calculate what m is, the gradient, and then we can multiply that out. So we multiplied that out, and then we solved our two equations. So that would be the question that we put to our students, and we came up with the answer that they intersected at 4, 3. So there you are. I think that's a logical place to stop tonight. I won't give you anything over we'll have a night off tonight, so no problem over there, and we'll have a look at something different tomorrow night. But we can see how these things are all interrelated. And that, for me, that's one of the beauties of mathematics, is that one thing leads to another, but it relates to something that we did previously. So now we've, without looking at them as separate topics, we can draw straight line graphs. We can sort of create straight line graphs to go through points. We can work out where straight line graphs intersect. There's lots of other things that we can do with straight line graphs as well, which maybe it might be a good time to have a look at that. So yeah, let's see what happens. This has been a maurieo presentation, recorded live in our lovely little studio in downtown Ngāruawāhia, the Big Smoke in Aotearoa, New Zealand, a place where Kiwis live in a paradise we like to call God's own country. Good night and good gardening to you all.